In this section, I would like to explain some important information that I believe will be very useful to help you understand the practical use of Karl Fischer titration. I will cover 6 items in this presentation. I will start with general points about Karl Fischer titration and then go into more detail about both coulometric and volumetric titrations. Fourth, I will explain how to treat actual samples. After a briefing about optional devices, I will close this presentation with some other miscellaneous information. Karl Fischer titration is applied in various industries to many situations and materials. Some examples are gas samples such as LPG and LNG, liquids such as oils and shampoos, and solids such as toners and pharmaceuticals. It is also widely adopted in the food industry. The most important feature that distinguishes Karl Fischer titration from other water measurements is that it measures moisture directly by chemical reaction. Measuring loss through drying, which is typical of other methods, has 2 disadvantages. One is that it measures not only vaporized water, but also other volatile constituents, and the other is that the measuring time sometimes becomes long. Another important feature of Karl Fischer titration is that it is able to measure a very wide range of water concentrations, from a few parts per million to 100% water. I would like to remind you that you can analyze samples in all states, solid, liquid, and gas, by using special samplers, optional water vaporizers, and gas injectors. I believe many of you already use either volumetric or coulometric Karl Fischer instruments. Volumetric instruments are usually used for high moisture samples, and coulometric instruments are for low moisture samples. The general criteria for choosing between these 2 titration types is if the water content of the sample is greater or less than 1%. Coulometric titration is suitable for relatively clean samples that do not make the cathode chamber dirty and that readily dissolve in the anode solution. Volumetric titration, on the other hand, could be used for colored or dirty samples, since it has only a detection electrode in the cell and no cathode chamber. The abundant choice of solvents for volumetric titration makes it also useful for difficult-to-dissolve samples. Solid samples, such as plastic pellets that do not dissolve in Karl Fischer reagents, can be measured by using a water vaporizer. Now, I will explain the details of the 2 titration methods. Firstly, let's consider coulometric titration. As mentioned in the previous slide, it is suitable for relatively clean samples, such as organic solvents and oils. We often receive inquiries like, I am planning to measure samples of 50 parts per million concentration, or I am wondering how to measure a sample of 3%. Since Karl Fischer titration measures the absolute weight of the sample water directly, it is important to consider not the water concentration, but the absolute amount of water. The ideal amount of water in a sample for a coulometric measurement is between 500 and 1,000 micrograms. The table illustrates, as reference, the preferable sample weights that are converted from this ideal amount range and the estimated water concentrations. This table shows the actual measured values, with examples of organic solvents and oils. The upper line is for insulating oil, and the lower line is for toluene, and they are measured with ordinary reagents, AX and CXU. I would like to explain how moisture in ambient air can influence the measurement while the sealing stopper is opened for sample injection. In a case where the stopper is open for 10 seconds under an atmosphere with a 24 degrees centigrade temperature and 74% humidity, more than 200 micrograms of moisture entered the titration cell. In contrast, under a dry atmosphere with a 24 degrees centigrade temperature and 10% humidity, the measured value is only 5 micrograms. By reducing the amount of time that the stopper is open, the moisture entering the cell can be reduced to below 50 micrograms, even in a humid environment. But even 50 micrograms can have a significant influence on the results when measuring very low moisture content samples. In these cases, it is recommended to measure these samples in a dry atmosphere, in a glove bag, for example.